Have you ever wondered what power factor is? If you've been around electrical systems, you've likely come across this term. But what does it mean? Well, it's a fascinating concept that's integral to the world of electricity. Power factor is the ratio of real power, the power that does the actual work, to apparent power, which is a combination of real power and something called reactive power. You see, in any electrical system, the power that's doing the actual work, like lighting up a bulb or running a machine, that's real power. But then, there's also power that's used to maintain magnetic fields in inductive loads. This is what we call reactive power. The apparent power is the combination of these two, real and reactive power. So, essentially, power factor is a measure of how effectively we are using electricity. It's a crucial concept, especially when it comes to managing energy costs and improving system performance. Now that we understand what power factor is, let's delve into what affects it. Several factors can influence power factor. First, let's talk about inductive loads, which include devices like motors. These loads have a unique characteristic. They have a lagging power factor. But why is this? Well, these loads require something called reactive power to function. This is the power used to maintain magnetic fields within the device. When an inductive load is operating, it tends to draw more current, resulting in a lower power factor. The second factor is capacitors. Quite the opposite of inductive loads, capacitors actually improve power factor. How so? Capacitors provide reactive power, which can help to balance out the effects of inductive loads. Think of it as a tug of war. On one side, you have inductive loads pulling the power factor down, and on the other side, capacitors are pulling it back up. The third factor affecting power factor is harmonics. Harmonics are distorted electrical waveforms that occur due to non-linear loads in the system. They can significantly lower power factor by increasing the amount of reactive power in the system. So, the cleaner your power supply, the better your power factor will be. But why is all of this important? Well, a lower power factor means you're not using your electrical power as efficiently as you could be. This can lead to higher energy costs and potentially even damage to your electrical systems over time. By understanding these factors, inductive loads, capacitors, and harmonics, we can start to see how we might manage our power factor more effectively. Whether that's by reducing the number of inductive loads, adding capacitors to the system, or ensuring a clean power supply, we have several tools at our disposal. Understanding these factors can help us manage our power factor more effectively. So how can we improve power factor? One common method is to use power factor correction devices like capacitors. These devices help by providing reactive power that counters the effects of inductive loads. In essence, they balance the equation, bringing our power factor closer to the ideal score of 1. As we've learned, power factor is the ratio of real power to apparent power. Real power does the work, while apparent power is the combination of real power and reactive power. Factors like inductive loads, capacitors, and harmonics can affect this ratio and thus our power factor. Power factor is not just an abstract concept. It's crucial for the efficient operation of our electrical systems. A good power factor means more efficient use of electricity. And who wouldn't want that? Remember, a good power factor means more efficient use of electricity. So, understanding and managing power factor can help reduce energy costs and improve performance. Thanks for tuning in, and don't forget to like, share, and subscribe for more insightful videos.